Alibaba tries to convince us that AI stands for Alibaba intelligence.
I call it Alibaba intelligence.
Yeah.
Oh, no, wait. That was Apple.
Introducing Apple Intelligence.
A humanoid robot is walking across the entire Great Wall of China to show how it can handle all sorts of different terrain. New online tool allows you to make any shaped iceberg you can imagine and see how it floats. So we found out this week that Apple's deal with OpenAI is actually real, and they mentioned them during the keynote. A Princeton AI project unlocked a new level of performance in fusion reactors. There's a new report where somebody actually did the math to find out how many tokens humans have left on the internet. Turns out that it's 300 trillion. But that's literally all the human data that AI can learn from. Fortune magazine used AI to analyze 24 years of SEC disclosures. They told it to look for ways to increase profits. Alibaba has open sourced a new AI model called Qwen 2, and it is powerful, outperforming Meta's Llama 3. And we're going to take a deep dive into just how does Apple's cloud compute work and why is it supposedly so much more secure than everyone else's. But first, let's check Alan's conservative countdown to AGI to see how close to the singularity we are, and 74% still. Enjoy the vacation while it lasts. Okay, so watching Apple's keynote, when Apple Intelligence came up on screen, I couldn't help but think of this from 4 years ago.
I hate the word AI called artificial intelligence. I call it Alibaba intelligence.
Yeah.
Did you hear those groans/laughs from the audience? So you might know that I'm not a big fan of artificial either. I think alien intelligence makes sense. I think alternative intelligence makes sense. I like ML, machine learning. I also like machine intelligence. I never thought it should be called Apple Intelligence. That's like the podcast.
And podcasting, of course, is a concatenation of iPod and broadcasting.
If you go back in time, there were actually people who were calling them netcasts because they were like, we don't want Apple to take over the podcast because it was for Apple iPods. But now look, everybody calls them podcasts no matter where they are. Like they took the brand. So I would not be surprised if in 5 years, like kids grow up thinking AI literally means Apple Intelligence. But we'll see if they win that battle or not. Don't be intimidated by that music. It's just going to be a robot walking. We've seen it plenty of times before.
The Great Wall, a witness to millennia of change.
The Great Wall has witnessed a millennia of change.
A new explorer had set a foot on this land.
The Great Wall of China is an ancient dragon that challenges every climber. And look at XBot.
Equipped with advanced perceptive reinforcement learning, confidently faces these challenges and marches forward.
Tackling it like an old man barely moving through his home. And what is this? Super hyperspeed? That it looks so weird with that music.
This challenges and marches forward.
I mean, look, I'm scared of robots. Bipedal robots are going to totally be a thing really soon here, but this is just not as intimidating as they're trying to make it look. And there's no way there's not some guy right off camera powering this thing up every once in a while. I mean, it did not walk the Great Wall of China without hundreds of recharges. That robot is conquering those steep slopes. So impressed. And now here's another clip of it pruning a plant. Imagine it can prune plants and walk the Great Wall of China. Future is now. Imagine any shaped iceberg that you want in your head. Now, because an iceberg is less dense than water, I almost bet anything that you can't imagine how, if you dropped it into water, it would float. There's always about 10% of mass above water, but how do you know which direction it's going to spin so that 10% that needs to go to the top goes to the top? Well, there's a new tool for that. This is Iceberger. You're imagining the Mickey Mouse ears? Boom. I mean, not the greatest Mickey Mouse ears. Listen, you're imagining a sideways Mickey Mouse ears? Let's see what happens. Oh. Well, there you go. What about a Nike swoosh? Oh, see, much more is above water than I expected there. How about alligator face? That's how they float too. You know that's how they float. All right, let's get to the big news that everybody's already covered. So we're going to think about this in a new direction. What is going on with Apple, with OpenAI, with large language models, with Apple Silicon? This has got to be one of those moments in Apple's history where if they get this right, I think they've got something special, but they could so easily slip up. What they showed at WWDC was not anything intelligent, but what they did was pretty intelligent as a company. And that was to think about the iPhone, the iPad, the MacBook, and the entire Apple ecosystem, the watch and the headset, as a place where AI can become part of the story, but in a very controlled and a very simple way at this point. Now, they should have their own model. Why aren't they taking something like Llama 3 and rebranding it as their own? Why didn't they partner with OpenAI in a way where they could actually take the model themselves and claim that it's Apple and just pay the royalties on the back end? Why they're going to continue being a platform that other AI can plug into is an interesting development. I think that Siri being an onboard AI, something localized that can choose when to go out into the cloud for different reasons, makes a lot of sense, but that thing better be good enough that it works in the same way that Microsoft's Recall will, or what the kind of integration that is going to come from something that Google builds in all of your doc systems, right? Your Google Docs, your calendar, your Gmail, all of that. It has to be something that feels seamless, even if behind the scenes it's intelligence and it's choosing what to do. So one thing I want to point out at the beginning is that if you look at the major tech companies, Facebook, Google, Microsoft, and Apple's really the only company that's truly not incentivized by advertisers. So I was really impressed with the way that they came out of the gate with local models and local control. And I like that they have servers in the cloud now that are built on Apple Silicon, so they have much more control over the privacy and basically the cybersecurity aspects. Now, are they going to use that in a way that actually makes that system much more secure, safe, and better for people like us? That's yet to be seen. But the idea of Siri actually being able to see what's on your screen, having on-screen awareness, meaning that it can understand what you're asking for, and it has deep integration in the way that normally an app couldn't, so it can actually switch between apps, is the same game-changing idea that came from Microsoft Recall. That means that you don't need an API for any kind of app. It just means that if you swipe and bring it up on screen, there is a computer vision model that can actually see that data and reinterpret it. So whether it's your calendar or it's Tinder or it's a game that you like to play, the vision system can look at what's happening on screen and take actions just like you. It can actually press buttons on the screen. It can actually learn in the same way that humans are what kind of apps you have and what your daily workflow is. And eventually that's going to become such a powerful assistant. And the fact that ChatGPT, powered by GPT-4o, will be installed in a way that the iOS can talk to it in a deep integrated way later this year is pretty amazing. So let's switch gears, go from the Apple thing to talk about a new model that came out of Princeton. And it is a very powerful model in truly the power sense because it is applied to fusion reactors. So in this laboratory, scientists are pushing nuclear fusion. So just in case you're not up on it, fission, like nuclear energy, means that you're actually breaking apart atoms in this like controlled, like exponential growth of like breaking apart. That's where all the energy comes from. Fusion reactors, and the reason why they really are special is they're doing the same thing that the sun is. They're creating immense pressure until different atoms actually compress and become a heavier element. You move up from helium to, I forgot the periodic table, but you move across the periodic table. So like hydrogen, helium, and then all the way up to like carbon and iron eventually. And the amount of energy that is emitted when there is fusion is absolutely incredible. But it's a really hard problem to solve. And one of the things that has stopped the scientists from making enough progress on these fusion reactors is that when you make this super powerful magnet and you have this plasma that's zipping around in it and it's getting hotter and hotter and hotter, you end up with these periodic energy bursts. It doesn't stay like a smooth thing to control. And the bursts are so powerful, they tend to throw off the magnetic field and in most cases actually even damage the reactors. And this is the problem that the Princeton students decided to tackle. They're using artificial intelligence to try to predict where the plasma bursts are going to happen. When does it become unstable? And how can the magnetic field be adjusted in just such a way that it counteracts the way that the plasma burst is going to happen? So we're talking about artificial intelligence making incredibly fast real-time adjustments to how the magnetic field compresses the plasma. And so far it's been successful in simulations. It's pretty versatile. It could be deployed at scale soon. And maybe this will be a key component to actually bringing the breakthrough that is fusion energy, a clean, powerful source of energy to the world. All right, so when it comes to training large language models like ChatGPT, there's a lot of words on the internet, right? You can read all of Wikipedia, you can read every web page. There's plenty of other data that's inside of databases that companies put up on social networks. But there actually is a limit to that. And what will AI systems learn from when those language tokens are all basically learned from? They'll have to generate their own, which might not be as good of quality. So some researchers actually decided to put a number on that. They tried to actually quantify how many tokens of text are out there in the entire world. And drum roll please, they estimated the stock of all human-generated public text around 300 trillion tokens. And if you look at the trends of what the newest Gemini, Claude, and GPT models are actually digesting, somewhere between 2026 and 2032, there will be no more human data for AI to learn from. So here's a graph that goes over time, right? So it goes from the 2020 to 2034. And on the y-axis, we're looking at the effective stock, the number of tokens that can actually be learned from. Now that keeps going up because in the future, we will keep generating more and more tokens. And in fact, say everything that I'm saying right now, if you're watching it on YouTube, there is a transcript to the right of what I'm saying. Those are all new tokens. So that is more text that it could learn from in the future. But the models are still eating up the tokens and learning from them faster than they're being generated. So you get to this crescendo where they basically sort of S-curve, this sigmoid curve off at the top around 2028, and then that's it. So at some point, the big question will be, can synthetic data fill in for human data and can it still learn in an intelligent way? So we'll see. Okay, so you know I love when somebody takes a really unique data set and finds an interesting question that they can apply artificial intelligence to on that data set. And that's exactly what the Rand Corporation did. They pulled up a full 24 years of SEC disclosures and they asked, what is the main factor that would have increased investor returns? I don't believe that there is any free lunch when it comes to finance. This is not investing advice, but this is one of the more interesting and intriguing things that I've seen in terms of like stock market performance. The Rand Corporation actually found that investors in the past, doesn't mean it's going to keep happening for the future, but they could have doubled the investment returns if they had put money into companies that had frontline workers. Basically, humans on the ground dealing with the customer. So you got to think about a retail company like Forever 21 or Home Depot, Target, any place like Costco where there's actually a bunch of human interaction with customers. And my theory would be that if you have a company that does interact with customers, but you can keep hiding behind layer after layer, like imagine a credit card company, for example. Like you don't actually deal with eye contact and a human at any point. Like you sign up a lot of times online, they send you the credit card, you call for support. It's always non-human interaction or it's human over phone only. But it seems to be that at least for the past 24 years on average, that when companies had to take care of employees who were on the ground, it turned out to be a win-win, boosting profits, made investors happier in the long run. All right, you guys ready for a brand new model, maybe even one that you haven't heard of, but is more powerful in many aspects than Meta's Llama 3? And yes, I said that right, Meta's Llama 3, the one that came out just a couple weeks ago and is the most advanced and most powerful open sourced LLM out. Well, they didn't have that title for very long, although you might not see a lot of people using this because this is Qwen 2 and it came from Alibaba. So GPT-4o said we should ask the Qwen 2 model, explain the significance of Gödel's incompleteness theorem in the context of modern artificial intelligence. Okay, that sounds actually awesome to hear the answer of, particularly in relation to the limitations of machine learning models, and additionally compare the Church-Turing thesis and discuss any potential misconceptions that might arise when applying these concepts to contemporary AI. Wow. All right, so it looks like Claude says Gödel's incompleteness theorem applies specifically to formal systems, but the Church-Turing thesis is a statement about compatibility, and Gödel's theorem and the Church-Turing thesis are primarily concerned with the theoretical limits of computation and formal systems. Dang, bro, I'm like not even on the level to know if they did the answer right. Let's see what Qwen 2 said. All right, so in conclusion, what Qwen 2 says is that understanding these concepts can help researchers and practitioners develop more realistic expectations for AI and guide the development of new algorithms. I mean, honestly, I'm not really even smart enough to know what a good answer is, but it feels like a nothing burger here. I'll take their word for it. Maybe more powerful than Llama 3, but the fact is China has got some powerful models out there for open source developers to work on, just like Meta does. So let's go check out Apple Security's research blog to learn a little bit more about how Apple Intelligence, AI, and the cloud are going to work together. Even though Apple has not created a large language model that's capable of the same kind of things GPT-4 is, it doesn't mean they haven't produced any models. They have been working on some smaller ones, especially trying to make it so that it can run on Apple Silicon. And I love this idea. I want my phone to have a language model that lives on it, that serves me as the user, does not go out on the internet and get commands and requests, but does that all locally. Now that's a tricky thing to deliver, but Apple does have some components that might make it better positioned to do that than any other company. One is that the iPhones and the new MacBook Pros that are running on the Apple Silicon have a certain level of security and functionality that Apple controls that are not general purpose, meaning there's a lot less attack vectors. They can have much more control over securing it. So if you have an Apple AI system looking over your text messages and you have a request that it can't handle locally and it makes the decision to send that data up to the cloud, first it's going to encrypt that data so that even if somebody was to intercept it, they wouldn't be able to read it. It would just look like a bunch of gobbledygook to them. And when it gets up to the cloud, it does need to be unencrypted so that their AI system, their larger cloud system, can actually do something with it and give you a reply. But it's like a Russian nesting doll or an onion. There's another layer of encryption on top of that. So even Apple employees, people who work on the servers, shouldn't be able to see anything that's happening inside that container. So it's unencrypted in this tiny little world where it's processed, and they understand what they've implemented to process it. They can't see what the reply is and learn from it. So it seems like a really unique approach. Hopefully this does set an industry standard, and hopefully this cloud privacy, this private cloud compute is really worth, buying Apple products for. Now it's time to transform into research. Grimlock, transform into research. It's research time. Okay, so the first paper we're going to look at today is called Open-Endedness is Essential for Artificial Superintelligence. Okay, so this paper goes into the idea that something that we're going to call, quote, open-endedness, it will be something that has to be figured out before we ever get to artificial superintelligence. And it suggests that before any kind of AI system can become superintelligence, it has to itself, in its own mind, start coming up with creative solutions. It has to come up with something that's surprising, like a relevant idea that surprises even it. And it needs to be in some kind of a feedback loop where it's continuously doing this. So arguably for us, to be really intelligent, we have to be sort of sitting there. And you've probably been tired. You've been sitting in a chair. You've been too tired to move, but yet your brain can keep churning. It can keep processing and thinking and coming up with new ideas. And these authors are arguing that even if we keep scaling up the kind of systems we have, these huge large language models, they're super capable. They're not going to do anything that's close to ASI without a big fundamental change in the way that they're built. So they're imagining some kind of architectural change where they're generating these new ideas and they're checking them and thinking about them and feeding them back into their own system in this constant feedback loop. And that if we can figure out what that mechanism is, not only will it give some incredible insight into how the human brain works, it might also have important safety and ethical implications for how AI evolves in the future. And there is this interesting part in the paper where they have an illustration of how you can maybe imagine open-endedness. So the definition of open-endedness hinges on a system's ability to continuously generate artifacts that are both novel and learnable to an observer. So consider a system that designs various aircrafts. So imagine asking this of a mouse. It might be able to find these designs novel, but it's going to lack the capacity to comprehend the principles behind them. Now, for a human who's studying aerospace engineering, the system offers both novelty and the potential for learning, so it makes it open-ended. That's the open-endedness definition as checkmarked, as fulfilled. However, a super intelligent alien, what we have here on the right, with a vast aerospace knowledge that goes way beyond any kind of human understanding or even all of the knowledge that we have about aerospace as a whole, might not find the design novel, but it would still be able to analyze and understand them. And that's what highlights what they're calling the open-endedness, where observer-dependent and novelty or learnability alone is not enough. Got to find that sweet spot in the middle where humans are. So next up, let's talk about this paper, one that I'm kind of reluctant to put in, but because it literally went viral. Somebody posted this on Twitter and I ended up getting like 500,000 reads. It's one of the most read archive AI related papers ever. So I felt like I just needed to cover it for that reason alone. And this paper called Scalable MatMul-free Language Modeling is such a big deal is because pretty much everything that we've been building in terms of servers has been about matrix multiplication. That's why GPUs that were originally meant for gaming and then went for like crypto mining and have all of a sudden become so important for AI. It's why NVIDIA, who is leading the charge on all of those GPUs, is now the world's biggest company. But what if there's a fundamental architecture change to something that is just as smart as GPT-4 and it doesn't require GPUs or matrix multiplication? Well, now we're talking about like a whole new direction for AI to go on, and that's why this is a big deal. Okay, and if you're not going to do matrix multiplication, if it's not about tensor operations, then what the heck is it? Like, what is going to change all of these weights and values and make the model learn? And it's using simpler operations. And you might be like, what's more simple than multiplication? Well, addition. MatMul-free model, like a basically math multiplication free model. And the experiments that are in this paper are showing that as the model size increases, that the performance gap between these MatMul-free models and the traditional models actually starts to narrow. And they actually go the extra mile, and they even present a GPU efficient implementation that reduces memory usage by 61% during training and more than 10x during inference. So training is when the machine is learning, inference is when you're actually asking a question of something like ChatGPT. I know it's pretty crazy when you think about it, and I can see why this could be a real fundamental breakthrough if it pans out the way that, that it might. I mean, we're still in the early stages. And they even hint towards the end that it could start to approach the efficiency of the human brain, which is many, many orders of magnitudes more efficient than anything that we have built right now. All right, so next up, let's talk about this paper. This is frequency masking for universal deepfake detection. Now, you might not be famous enough yet that deepfakes of you are rampant on the internet, but it might happen very soon. And when that day comes, we're going to want efficient tools for tracking down our deepfakes and eliminating them from the internet, and that's what this paper is all about. So this is what they're doing to find deepfakes. The system itself is invoking subjectivity and selectivity to each image. So basically they're obscuring parts of an image. Imagine taking an image and just like blurring parts of it randomly in different ways and keep feeding it in and out of the computer over and over again. And then what they're doing is actually measuring how quickly the system can identify something. And when it's an actual person, like a real face versus a deepfake face, the system is actually just quicker at noticing what blurry part is missing because it makes more sense in a way to the system. So think of how interesting of a solution this is. Instead of actually looking for any spatial components, it's not trying to see like, do the fingers look natural? It's not trying to make an assessment about the quality of the image. It's trying to blur and test how fast it can actually identify what's missing. And in deepfake images, it hesitates longer. So it just sets aside everything that it hesitated on, and it says those are the label of deepfake, and it turns out to be pretty accurate. I mean, I was like, this is insane that it actually thought of a solution in this way. This is not like anywhere where I was thinking it was going to be when I started reading the paper. And their findings show a significant improvement in detection performance compared to traditional spatial masking methods, and it underpins the potential of frequency-based strategies in the ongoing battle against digital deception. There you go, man. Plenty of mind benders in today's research section. And my final one might not be totally the same mind bender, but it's a very fascinating paper in its own way. And it is called 4-Bit Shampoo for memory efficient network training. And no, it's not like shampoo like you would have in the bathroom. It's a different technique. Okay, so we're going to talk about bits, 4 bits, 16 bits, 32 bits, you know all the bit numbers. And the goal here is to make an AI system more memory efficient without sacrificing any performance. Traditionally, any kind of a system that handles this big matrix multiplication just needs a lot of memory to hold all of that information while it's being processed. But instead of having a 32-bit matrix, you can actually compress it, and you do lose a little bit of information, but you can compress it down to just 4-bit precision, and still overall the system tends to learn fairly well. And it learns while saving a lot of memory, which means the training runs are way cheaper, or for the same amount of money, you can train them for much longer. And the trick that they came across in this paper is something called quantized eigenvector matrix squishing, I'm going to call it, compression. And they tested this on various image classifications, and they showed that the 4-bit version worked almost as well as the full 32-bit one, but with much lower memory usage. So there you go. We can actually get a lot more out of a lot less. Okay, so those of you that have been following me on this journey, let's take a look at my video from 3 days ago, see if there's anything that we can learn together. All right, so we ended up with 5,600 views from my video 3 days ago. Now, a couple months ago, I would have been ecstatic about this. It's a little bit Actually on the lower end of my average recently, but I don't mind because I've been on a really good run here. And it still gave me 65 subscribers. It made $35. And also this is a new record for female viewership, up at 2.3%. So I like that that's going up. We lost a little bit in the 18 to 24-year-olds, but more of the 65-year-olds are tuning in. So I guess I'm kind of moving up the age bracket. But it would be worth pointing out that normally it's all ad revenue, but look at how many super thanks I got. I got $14 from super thanks. So I appreciate that. If you guys want to drop a super thanks, I know that's a good signal for the algorithm, which is actually the main reason why I ask. But of course, that is money that goes directly into my pocket. So it's also awesome that you guys are supporting the channel directly like that. Now I'm going to leave you guys with a rap song from my 3 favorite chapter markers.
Alibaba intelligence versus Apple intelligence. Humanoid robots watch the Great Wall of China. New tool lets you draw an iceberg. See how it will float.
See how it'll float. We'll see you guys in the next video. Hit subscribe. Get more AI news from Dylan Curious.